Hello there, Mr. Sutton here, bringing you the AB Calculus 5-4 classwork solutions on RAM Part 1. On this first problem, we want to approximate this quadratic's integral from -4 to 4 using LRAM over 4 subintervals. So to do this, let's make a table, and we're going to use, since we have a distance of 8 over 4 subintervals, we're going to go by 2's. So we're starting at -4, then we have -2, 0, 2, and 4. Let's go ahead and get all the y values here. So let's see, this is going to be 16 over 2, so that's 8, plus 4 is 12, plus 1 is 13. Next, we've got 4 over 2 is 2, plus 2 is 4, plus 1 is 5. Then we have 0 plugged in there. That just leaves us with 1. That was an easy one. And then we have 2. That's going to be, let's see, 2 minus 2 is 0, so we just end up with 1 again. And if we plug 4 in, we've got 8 minus 4 is 4, plus 1 is 5. There we go. Next, to approximate this, we're going to pick all the left possible y values for each rectangle. So approximating this, we can say that this integral is approximately equal to, we have a base of 2 times a height of 13 for that first rectangle. Again, we're picking the left one every time. Next, we have a base of 2 times a height of 5. Base of 2 times a height of 1, and a base of 2 times another height of 1. Adding all those up, we got 26, plus 10 is 36, plus another 4 is 40. Next up, we've got 4 over 2 is 2, minus 2 is 0, plus 2 is 2. Then plugging in 0, that just gets rid of everything with x, so we're left with 2 again. And plugging in positive 2, we're going to have 2 plus 2 plus 2, that's 6. All right, so we only have one choice for the height of each rectangle. These are the midpoint heights. Each rectangle has a base of 2, so we've got the approximation of the integral of f of x from -5 to 3. That's going to approximately equal 2 times 6. And again, note the squiggly approximately equals here because we are approximating. Then we have 2 times 2, 2 times 2 again, and 2 times 6. So that's going to be 12 plus 4, and then do it again. That's a grand total of 32. On this problem, we're trying to approximate the area under this function using RRAM over -6 to 4 with 5 subintervals. So we're going to start at -6 and go by 2's because we have to cover a distance of 10 in 5 shots here. So then we have -4, -2. These are all the x values now. 0, 2, and 4. And now we have to get the y values. So we're going to have, this will be 36 over 2, which is 18. Minus 6 is 12, plus 1 is 13. Then we have 4 squared over 2. That's going to be 8 minus 4 is 4, plus 1 is 5. Then we have -2 squared over 2. That's going to be 2. Minus 2 is 0, plus 1 is 1. Plugging in 0, we zero out everything with x, so that's 1 again. Plugging in positive 2, now we've got 2 plus 2 plus 1, which is 5. Plugging in 4, we've got 8 plus 4 plus 1 is 13. Now we're going to do our rectangle areas. These each have a base of 2. For the heights, we're going to use the right side of each rectangle. So approximating our integral from actually that should be -6 to 4. There we go, -6 to 4. We're going to start with the base of 2 times height of 5. Again, we're using the right side of each rectangle. And note the approximately equals. This does not exactly equal all of this stuff because we're using just rectangles to estimate here. Next, we have a base of 2 times a height of 1. Base of 2 times a height of 1. 2 times 5. And then a base of 2 times 13. So that's going to be 10 plus 2 is 14. Plus 10 is 24. Plus 26 is 50. For this problem, we're trying to approximate the integral of 0 to 9 of f of x with these table values for f of x using RRAM. So this integral is going to approximately equal, we have a base of 1 times, we're going to use the height of 3. Since this is RRAM, we're using the right side of each rectangle. Next, from 1 to 3, we have a base of 2, height of 4. And we're going to add to that a base of 1 times a height of 3. And next, we have a base of 5 times a height of 2. So that's going to be 3 plus 8 is 11. This is going to be 14, 24. For this problem, we need to approximate the integral from 0 to 13 using LRAM, and f of x is given some selected values in this table here. So we're going to take the left side of each rectangle when we do this. Approximating this now, we have a base of 3 times a height of 7, because 7 is the left side of that first rectangle. Next, we have a base of, from 3 to 8, we have 5, height of 9. Next, base of 1 times a height of 8. Base of 3 times a height of 6. And a base of 1 times a height of 4. So this is going to be 21 plus 45 is going to be 66, plus 8 is 74. This is going to be, let's see, 92 and then 96. For this problem, we're trying to approximate f of x, the area under f of x rather, from 0 to 20, given these table values, and we're using RRAM. So we can say that this is approximately equal to, we have a base of 1 times a height of negative 4. We're using RRAM, so we pick negative 4 instead of 6, the right side of the rectangle here, the right y value. Next, we have a base of 6 times a height of negative 6 that we're adding in there. Base of 2 times a height of negative 7, plus a base of 10, that's a big jump, times a height of negative 6. And then finally, base of 1 times a height of negative 4. So this is negative 4, minus 36 is negative 40. This will make it negative 54. This will be negative 114, and then negative 118. For this no calculator problem, we are given the function 9 to the x. We're using 4 subintervals of equal length and want the value of a right Riemann sum approximation of this function from 0 to 2. All right, so we can say that f of x from 0 to 2 integral is approximately equal to, so we've got essentially 5 different x values we could use here. Since we're using 4 subintervals and we're going from 0 to 2, we've got 0, we've got 0.5, 1, 1.5, and 2. They want a right Riemann sum approximation, so that first rectangle that we would be making that goes from 0 to 0.5, we're going to use 0.5 as the y value. So we're going to say that this is approximately equal to, we've got a base of 0.5 times, let's see, we've got 9 to the 0.5, or 1/2, either way. So this 0.5 is the base, and that's going to be the same for the other 4 rectangles. And we're doing, again, 1/2, because that is the right y value. 9 to the 1/2 is the right y value of that first rectangle. Next, we've got plus 0.5, base of 0.5 times 9 to the 1, and then 0.5 times 9 to the 3/2 plus 0.5 times 9 squared. All right, let's see what all this comes out to. So for this first one, this is 0.5 times the square root of 9, which is 3. So 0.5 times 3 is 1.5. Next, we've got half of 9, which is 4.5. Next, let's see, this is the square root of 9, and then we're cubing that. So that's 27. Half of 27 is 13.5. And then finally, this is half of 81, which is 40.5. This was a no calculator question, so we had to do this without one. So this is going to be, let's see, 1.5 and 4.5. That's going to be 6. And then these two values here add up to 54. So that's going to be a grand total. 6 plus 54 is going to give us 60. It's a nice whole number. That comes out to choice C. For this question, we're given a continuous and closed function on the interval from 2 to 13. And we have some table values for it. Using these intervals that they've given us here, which is essentially just here to here, here to here, here to here, and so on and so forth, we want the approximation of the integral from 2 to 13 with a left Riemann sum. So we're going to do base times height and add a bunch of these rectangles together. The first rectangle has a base of 1, and we have a height of, well, this is the left Riemann sum, so we have to use the left y value here, 6 instead of negative 2. So we are approximately going to be 1 times 6, height of 1, or rather base of 1, height of 6. And I'm putting approximately equals because it doesn't exactly equal this. It's an approximation. It's multiple choice, but I like to be mathematically correct anyway. So next we have a base of 2 from 3 to 5 times a height of -2. Again, we're choosing the left height every time. Next, we have a base of 3 times a height of -1. And finally, a base of 5 times a height of 3. So this is 6 minus 4 is 2, minus 3 is -1, plus 15 is 14, gives us choice B.